Okay, so we're doing a unit on algebra, and I don't know whether maybe I don't tell you guys this enough, but you guys have come so far in a month. Like, if you think of what we've accomplished in a month of working on algebra, if I would have told you that you could solve the equations we're solving a month ago, I bet you would have been like, no. Right? When you think about it, like, your algebra skills have come a long ways. They still have a ways to go, and mostly that, I think, can be attributed to you got to not make dumb mistakes. Right? Because I'd say most of you have the skills you need, probably for the most part, right? Occasionally you just don't see what to do and you go, I just didn't see it, right? But I'd say for the most part, you have the skills. And that's where, especially Dash 1 math starts to go, is that it's about execution now. You know, don't make a little mistake. It sounds so simple, but it's hard, right? So here are some of the skills we've learned over the course of our unit. We relearned how to FOIL and factor. That should be a skill you know how to work with. We learned how to solve quadratics, specifically using the quadratic formula. That's a good way of solving. We also, if you did the Dash 1 stuff, we talked about how to solve systems of equations, where you get two equations with x and y. Can you guys grab that door, please? Where you get two equations and you've got to solve for x and y. Far so good? And then most recently, we were working with how do we deal with equations that have square roots. So I'm going to repeat this a lot just so that it sinks into your head. How do you solve a question that has square roots?
Square.
When? At the right time. Don't just go squaring away. Get the square root by itself and then square both sides. Does that make sense? Okay, so my goal today now is to continue working on our algebra skills. Factoring and foiling, still important. Being able to isolate for x, still important, right? Like, those skills don't go away. We're just adding a new one. To be honest, actually, we're not actually adding a new skill. You guys at some point have learned how to work with fractions, I'm sure. It's just now we're taking it to like the nth degree and we're making it, you know, hard. So today and yesterday and whatever their next day is, we're talking about rationals. We want to work on skills with fractions. In general, when you want to work with fractions, the key to fractions is you want to cancel top and bottom. Right? But you have to make sure that you cancel at the opportune moment. You don't just start canceling stuff because you see, oh look, it looks like it can cancel. There are very specific rules about canceling. Monomials can cancel monomials, and binomials can cancel binomials. Does that make sense? Right. Today's goal then, how do we deal with stuff if we have to add and subtract? And the key word here then, or two words I guess, common denominators. Which is like the bane of your existence. This is, I don't know that it's harder, but it's a lot more work. It just means more chances to make mistakes, I guess. So here's a picture on the side then of something that I'm sure you learned how to do at some point in your life. If a teacher asked you what's 1/3 plus 1/2, can you add these things? And the answer is no. They don't have common denominators. In a way, it's kind of like me asking you to add 3x and 2y. They're not compatible. Does that make sense? So we need to try to find a way to make them compatible. There's a nifty trick that you can play then. You can always multiply by 1. 3 over 3 is essentially 1. That's valid. And over here, I can multiply by 2 over 2. How did I just come up with those numbers? Yeah, the common denominator, if I multiply them together, the denominator is 6. So like 2 times 3 on the bottom gives you 6. 2 times 3 on the bottom gives you 6. That way we're now talking about the same thing. And so on the top, 2 times 1 is 2, and 3 times 1 is 3. 2 sixths plus 3 more sixths. It's almost like you could write it like this. 2 sixths plus 3 sixths. You see how like this is the same as this? Therefore you have 5 sixths, which means it's like 5 over 6. But that's the skill. What was that? You guys have seen that at some point before, right?
Yeah.
Okay, so now let's use that skill in solving questions. That's it. So let's do some examples. So first question. These guys right here, is there anything, before I even try to deal with the fractions, is there anything I can cancel? No. Unfortunately, like, there's just not on this one here. So now I need to try to figure out how do I deal with the subtract sign. And in order to subtract, they have to have common denominators. So I started off easy here. They do have common denominators. So the common denominator is m. Really important teaching moment here then. On the top, you are doing m minus m. M goes away. What's left on top?
-1.
Good catch, -1. Why -1?
So you're subtracting it from 0.
Yes, it's almost like you have nothing right here in terms of numbers, and you have nothing minus 1. Be very careful when subtracting, because often what kids will do is they'll say m minus is m, and then they'll ignore the last little bit and they'll say, look, there's a plus sign right here. But in a way, it is a minus +1, and then the minus will take precedence. Let's try another one. Do these guys have common denominators? Okay, I'm making them easy to start with, obviously. So your denominator is 4q minus 3. You have 10p, and you're subtracting -2p. So really you're adding. So you have 12p. Does that make sense? And then you have -1, and you're subtracting 8. -9. Can I take this 9 and this 3 and cancel them? No. Why not? They're part of binomials. Is this binomial here the same as that binomial there? No, unfortunately not. So there is one more thing we could do. I said last day, when you want to figure out whether you're done, the key to being done is there anything else that's more useful? I want to show you something that you could attempt to do, but I wouldn't require this because it's not useful. The top of this fraction you could actually factor. 12 and 9 have a common factor of 3. So you could take out a 3, and it would leave you with 4p minus 3. And then on the bottom, you'd have 4q minus 3. That is so close to being the same, isn't it? But it's not. So was this actually purposeful?
No.
So, I mean, I wouldn't mark you wrong if you went one step further and you attempted to try to factor so that you maybe could cancel. But this right here would be correct. There was nothing more purposeful that you could do. Shelby.
But once you see that no matter what you do, it wouldn't cancel plus p.
For sure. So you might not even bother trying. I wanted to make that a moment to kind of show you that. If this up here was not p, if it was q, then for sure you should do that. Because hopefully you'd see those would have canceled if I had made the letter different. How are we doing so far? Cool. Okay. This is kind of one of those lessons where I just do examples. Tell you we're sick of examples. Okay. New example. Do we have common denominators? Okay. No, we don't. No, we don't. Okay, so now we need to try to figure out how to get common denominators. And that's a little more challenging than just with numbers, because like way back on our first slide, with numbers, you just, you times by like 3/3 and 2/2. Does that make sense? But it's a little bit more challenging when we're working with like x's as well. So the advice I would give is before you do anything, factor what you can. Because there's actually something here you can factor. Yeah, that x minus 1 is the difference of squares. So make it x minus 1 with x plus 1. Does that make sense so far? Okay. Talking out loud. Alright, everybody okay with that first step? Okay, I'm going to ask another question. Well, I'm going to ask two questions. Do we have common denominators? No. Do we have slightly common denominators? Yes, we do, actually. Hopefully you'd see that this x minus 1, or x plus 1 right there, is slightly in common with that x plus 1. Does that make sense? Yeah. It's not going to be that unusual that you will have slightly common denominators, where there's something kind of the same. So we need to multiply this fraction right here by something over something to make it so that it's the same as this guy right here. So multiply it by x minus 1 over x minus 1. That makes sense? I'm essentially multiplying it by 1, but now I have entirely common denominators. Well, this is like timesing by 1 though. Does that make sense? And we're not dealing with an equation. So like if this was equal to something else, we could do something to every single term. But this is a valid mathematical, I don't know, move because it's like you're timesing by 3 over 3. Does that make sense? Timesing by 3 over 3 is like timesing by 1. That doesn't actually change anything. Okay, before I go further though, there's one thing I have to do now. The top right here, I need to FOIL it. So before I go too much further, I want to FOIL the top. So you're going to have 4, and then you need to add 3 times x, so that's 3x. And then you got to go 3 times minus 1, so negative 3. This is the top of our cumulative fraction. And the bottom of our fraction is now x plus 1, x minus 1. Which one's plus? There we go. Yeah, that's a big step there. Make sure I explain what just happened. See how both of these fractions right here have the same denominator? Rather than having 2 fractions, I now have 1 fraction. So I have 1 big fraction. And I just have a single denominator. Rather than having this one and this one over here, there's just 1 sitting right here.
Can you always do that?
Yes, for sure. That's kind of the point. Rather than having 2 fractions, you have 1. However, the top of the fractions, I have to make sure that I combine those by adding. So you have a 4 right here, that one right here. And then this 3 times by that x to give you 3x. And this 3 times by that minus 1 to give you minus 3.
Can you do that with subtracting too or something?
You can do it with subtracting. I'm sure I have an example for that later. What would happen though is if this was a minus sign, is you would take minus 3 and FOIL it into x, and you'd take minus 3 and FOIL it into minus 1. That's all. I'm sure I have an example of that later. So, okay, any thoughts as to what else we could do?
Put the 4 and the negative 3 together.
Fantastic. So you could go 3x plus 1. The bottom. We could FOIL the bottom. But again, ask yourself the question, what good will that do? Will it cause something to cancel? No. So you may as well just leave it as x plus 1 and x minus 1. The top is now a binomial, and the bottom has a couple of binomials. Can any of them cancel? We're done. Don't try to take this 1 and that 1 right there and cancel them, because that's not valid. They're part of binomials. Occasionally what will happen is this thing that's left on top, it actually will be able to cancel with something on the bottom. That actually occurs once in a while. Alright, how'd I do on that one? That makes sense. Cool. What was that? Well, I mean, we're building, right? I mean, I don't know. Does the term scaffolding mean anything to you guys? Oh, okay. A scaffolding kind of refers to like, oh, you start at step 1 and then build a little bit more and a little bit more, right? So my goal as a teacher is to start off with basic ones to build your confidence, and then eventually, if we want to jump right to the stupid hard ones, then let's go do this one. Not yet? Okay, so let's keep working our way up. Let's try this one then. Okay, so first things first. Do they have common denominators? Clearly not. So we do have some skills of foiling things, though. Not foiling, factoring things. Some of these things can be factored. We should try factoring. So the x minus 1 up here, not factorable. But this x squared plus x minus 6, that's factorable. Do you have it?
Yeah.
What is it?
Minus 2 and x plus 3.
Thank you.
Wait, what?
X minus 2 and x plus 3 will do it. Oh, were we not on the same one here? We need numbers that add to give 1 and times to give -6.
Yeah, now I'll get it.
Oh, okay. So far, so good? Now you got it? Next one. Alright, next one.
Same thing.
Well, it's not the exact same thing, but like, what does it factor to? Good. You guys okay with being able to do that though?
Yeah.
Maybe not that fast, but you can handle that?
Yeah.
+1.
That's an x plus 1, yeah. Sorry, I will. Let me see if I can do a better job of dictating that. I feel like I do a pretty good job of writing on this tablet, but it is.
Yeah.
I like this way better, by the way, than like standing at the board.
Yeah.
What do you guys think?
Yeah. Then you're like not away from your brain.
Yeah. I'm also a little bit closer as well. Okay. We're good up to this point here? Okay, let me ask you a question. Do we have common denominators?
No.
Do we have partially common denominators?
Yes.
Yeah. Let me highlight them for you. Highlighter, let's go with green. That looks like fun. This and this are already in common. So what we have to do then is make it so that the x plus 2, no, sorry, x minus 2 that this guy has over here, this guy has an x minus 2 that this guy over here does not have. So I'm going to put one on the top and on the bottom.
No, you can't. You don't have them. What was the last one we did, like, what was common and then times?
Well, like on the last one, we took what was common, which was the x plus 1, right? And then we took the other one over here and we put it on the top and bottom.
Oh.
And that's essentially what I'm trying to do here, is this x minus 2, I'm putting it right here and here, because this one has an x minus 2, and this one in purple did not have an x minus 2. So I'm giving it an x minus 2, but it has to go top and bottom though. Yes.
Yeah.
Okay, how does canceling rules work? You need something on the top and on the bottom.
Yeah.
You're talking this one over here and this one over here? Okay, binomials though. This is all a term, and this is all a term, and they're separated by that minus sign. Does that make sense?
That x minus 2 is on the other side of the minus sign.
Yes. So that's no longer cancelable. Let me give you a different example then. Let's say I gave you 9 over 3 minus 3 over 1. Okay. We know that 9 over 3 is just 3, right? And we know that 3 over 1 is just 3. So this answer should be 0, correct? Would it be fair to cancel those 3's then? And then say that somehow this 9 over, I guess that would be a 1. And then I guess that would be a 1. 9 over 1, that would make it 8. That makes sense? And that's not how
Josiah
that works.
Delaney, please come down to the office. Josiah.
You know what, that was a great teaching point though.
Mrs. Marulli's grade 8
This x
English.
minus 2,
Please go to
this
room
x minus
211 for class today. Again, grade 8 English with Mrs. Marulli. Please go to room 211.
Okay, hopefully I made my point. This x minus 2 and this x minus 2, although one is on the top, one's on the bottom, they are in different terms. So that's not okay. Does that make sense?
Did we do that yesterday?
But we were multiplying yesterday. Does that make sense? That's the key difference, is yesterday we were multiplying. And so that's kind of like in chemistry when I give you a grams over moles, and then we multiply by a mole over here. That's valid. But if I give you a grams over moles, and I added a moles over here, that wouldn't actually work. Pretty good on that? Okay, great learning moments there. It's good to sometimes find common mistakes so that hopefully you don't make those. Does everybody then get that there was an x minus 2 over here, so I put 1 on the top and bottom here? Okay. Now I'm going to re-grab my highlighter and say my common denominators are getting, just a crayon I guess, there. We're getting closer. However, there's an x plus 1 right here that is still not on this term over here. So I'll grab another color, I guess. Where's the pen? Yeah, I'm going to put an x plus 1 here and here. No, I put it on the right-hand side, but you could have put it on either side. How am I doing so far? Okay. We now have entirely common denominators. That's good. Good news. We can now write it as one, I don't know, superfraction. Superfraction. The denominator is x minus 2, x plus 3, x plus 1. That's the easy part. The less easy part is what the heck goes on top.
Foil.
Exactly. Foil. So maybe to keep things clear, you guys can probably jump ahead steps if you like, but just to make sure that I'm doing like in little steps, I'm just going to rewrite this again. But if you wanted to skip ahead a step, you probably could. So now I'm going to foil. X minus 1 and x plus 1 gives you x squared minus 1. That's this bit right here, like when you foil that. Technically there's a plus x and a minus x, but I've kind of already gotten rid of those. What about this guy over here? What does that stuff foil to? Well done. Yeah, you got it. Does that make sense? Let's see if I can even color coordinate this just to make sure it's clear. This stuff right here turned into that. And this stuff right here turned into that.
So would there be a negative sign in between them?
Good, that was the point I was going to make though. We have to be super duper careful here. There is a negative sign in between here, like a big negative sign. Maybe I should even like, I don't know, like put this stuff in brackets just to make sure it's clear that we have to subtract everything over here. Don't just subtract the x squared, but we have to subtract all of these terms. This is all still over top of x minus 2, x plus 3, x plus 1, by the way. Okay, let's subtract the stuff that we can. X squared minus x squared is gone. Goodness. Minus 1 minus plus 4. Good. And then you have a minus 4. X. Plus 4x. And on the bottom, you have x minus 2, x plus 3, x plus 1. You could try foiling the bottom. Why? What will it help? What is the goal of fractions? To cancel when appropriate. Is this the appropriate time? Actually, there is no further appropriate time. Nothing will cancel. Okay. I will point out, though, again, occasionally what you're left with on the top here could end up being one of these binomials. And it is possible that you actually could cancel. I think I've got an example of that coming up eventually. How are we doing so far? I say this a lot too, especially in my calculus classes if I ever teach Math 31. I find that with math especially, there's like, I think 3 different levels of understanding. There's the first level, which really is like, I didn't get it. And there's the second level, which is, I just watched you do it, and I understand. And then there's that third level, which is, now I can do it by myself. So, want to try one by yourselves? Embrace the challenge. Try one by yourself. See whether you can do it yourself. I'm giving you all the skills you need. It's just, can you now apply these skills? So hard though, isn't it? So hopefully some of the first questions you're asking yourself, do these things have common denominators? No, they don't. You can factor. Did you forget to factor? Well, you can't actually factor that x squared minus 20, unfortunately, because 20 doesn't square a root. But you can factor the x squared minus 4. What will end up happening is when you then ask yourself the question, do I have common denominators, you'll say no. But do I have partially common denominators? Then you'll say, yeah, you do.
So it's 8x minus 2 on top, and then you have to put another x minus 2 if common denominators.
Right.
Factor that.
Foil it.
Foil.
Because like on the top there, you'll have x minus 2 and you'll have another x minus 2. Foil that, yes. Yeah. So that should have been your first step. If you want to just double check yours with mine, you should have factored the x minus 4 difference of squares. Step 1 done. Step 2, Shelby was just mentioning this here. You need to basically make it so that you've got your x minus 2 on this guy over here because you didn't have an x minus 2 on the second one. So that would be step 2, in case you're like absolutely lost. So it'll be x. Here, maybe come over here. That's. Well, it's multiple.
You said negative 4.
It's 2x squared subtract 4x subtract 16 over x plus 2 times. And I'm individually stay together. You can't.
That'd be x squared.
Okay, here's the next step. Now that I had common denominators, I put the denominators collectively together. So I guess what I mean by that is you had x plus 2x minus 2. You had the same thing over here. Don't have one fraction, have a superfraction. Put them all together. Superfraction. And then I foiled this little mess over here. What should happen then is the very top should all go together and give you 2x squared minus 4x minus 16. Out of curiosity, anybody able to get up to that point on their own? Nice. Well done, guys. Are we done? Actually, we're not. There is some stuff we can do on the top, actually. And we should at least make an attempt at it. Now, first thought I have, actually, this is a 2, that's a 4, that's a 16. They're all divisible by 2. Now, I can't just, like, cut them all in half, unfortunately, because I don't have an equal sign. But what I can do is I can factor out the 2, and it'll leave me with x squared minus 2x minus 8. Does that make sense? So since all of these terms have a 2, I divided out the 2. But it's sitting out front. I'm not like just omitting it entirely. This thing right here is a trinomial that you can probably factor. We need numbers that add to give minus 2 times to give minus 8. Add to give minus 2 times to give minus 8.
Yeah.
2 and negative 4 would work, yeah. So you can keep the 2 out front, and then when you say it can be negative 4 and positive 2. Hey! Someone just had a light bulb moment. So if you didn't hear what I think Jamie just said there. There is something now that you can cancel, which again is kind of the whole point behind fractions. Is we'd like to attempt, if possible, to cancel stuff. It's not always possible, but in this example it was. There's an x plus 2 right here and here that are on the top of the fraction. They are binomials that are the exact same. There's no plus sign in between them. So your final answer is 2 bracket x minus 4 over x minus 2. That being said, if you guys were able to get up to here, you're close. It just means you have to consider just a little bit further as, is there anything more we can actually do? And there was. What was that?
Who's in the army? But I work in the army.
Are you good?
Yep.
Question?
Oh.
Oh, it's destruction. How you guys doing?
How can you like cancel the x plus 2? This isn't like a binomial on the ball.
Well, there's a binomial right here of x plus 2 before I scratched it out. And there was a binomial here of x plus 2. One is on the top, one's on the bottom. But they aren't separated by a plus or a minus sign. So then it is valid to cancel because they're directly next to each other. What is math? Maybe one way of thinking of math is just a collection of skills that you use to solve problems. And in a way, maybe this sounds kind of, I don't know, I don't mean to undermine this, but I've taught you guys so far this year maybe only 5 or 6 skills. And most of them you knew. Most of what I think my job at this point here is to help you refine those skills, because you guys know how to factor. You've done it before, right? You guys know how to add numbers and subtract numbers, and maybe you're not great with fractions, but you've done those before, right? That's basically what this whole unit is taking a variety of different skills, factoring, FOILing, common denominators, square roots, right? And just figuring out what rules you can apply and when, so that it's useful for solving your problem. That's basically what algebra is. Okay, here's a flowchart that maybe you might find useful. Or maybe it's completely useless. I don't know. But I made this one year. Some kids liked it. Here's some ideas for how to solve stuff. First step is always factor everything. Factoring is always a good idea. Then, question, are you dividing? If you're dividing, flip the second one upside down. If you're multiplying, all you have to do is put the numerators and denominators together and start canceling. That's actually the easy one. Today's route is factor everything, then get yourself common denominators. If you are adding, things are good. If you're subtracting, don't forget to distribute the negative. By that I mean, like, don't forget that you have to sometimes like use a double negative when you subtract, because let's give you an example. If you had x plus 4 and you were subtracting x minus 2, you end up with 6. Because the 4 and the minus 2 actually means add. Does that make sense? So I just put an extra little thing here. Don't screw up the negative. Last step, factor the numerator if possible. And that's what we just did right here. This step right here was factorable. So factor it if possible, because it may be possible to cancel. And then finally you're done. Yay! Alright, why don't you guys take a 5-minute break, and then when you come back, let's try the, like, beast of all questions. Yeah. Yep. Well, let's take a break before we try to tackle this guy. Any thoughts? Where do we start? Factor, yeah, we can factor a lot of this mess. You have the skills. Just don't make a mistake. Can you factor 2x squared minus x? You can. There's an x in both of them. I'm going to try to do colors to keep it straight here. This will be x with a 2x minus 1. What about the denominator underneath it? You can factor. What can you factor?
X.
And it'll leave you with a?
X times x.
Fantastic. Pause. Pirates of the Caribbean time. Now is an opportune moment.
Yay.
Do you guys see the opportune moment right in front of you here?
Yes.
Perfect. Let's do it right now. Does everybody see that? Okay. Now is an opportune moment. Cancel those X's. Okay.
Now you're gonna go and do the Harry Potter.
Yeah.
Huh?
Harry Potter, another Potter.
I'm not doing that.
Okay, let's do the next one, guys, before we get too distracted. Top binomial or trinomial up here. Someone help me find numbers that add to give -1 times to give -12.
Positive 12. 44.
Some sort of 4 and 3 combo. Sorry.
Good day for you guys.
+3 and -4.
Hey, what's the... That doesn't work. Here.
When we put another one, can you get rid of the X and the X, or the X plus and the X plus
We have another opportune moment here. Good catch.
You can cancel the X plus three.
There is a multiply in between here. There is an X plus 3 up here. There is an X minus 3 down here. You know that term scaffolding I mentioned a while ago? I really purposely try to show you guys things in steps so that hopefully you have that light bulb moment where you go, wow, yeah, that, hopefully that makes sense to you. Devin.
Since separated by multiplication sign, can you split that?
That is okay. Separated by a multiply sign is okay. Separated by a plus or minus sign, not okay. You guys still with me? I'm starting to get a little distracted. I got like, can you guys give me 5 more minutes of attention? Okay. Focus. Jessica. 5 more minutes. Everybody back? Okay. This bottom trinomial, a little less fun to factor, but we have the skills. We've practiced those. So as a bit of an aside, like I'm going to go, I don't know, way over here. We need to do 2x squared minus 3x plus 1 and find numbers that add to give -3 and multiply to give 2. But we don't just get to hop right to those values because of that leading coefficient. We have to split it in pieces and go like -2x minus 1x plus 1. That makes sense? You guys can probably see in a way why did we have to start with a review of factoring, because it's going to come up. So, all right, cut it in half. Common factor this. There's a 2x in both. Leaves you with x minus 1. This is kind of gross, but like there's a 1 in both. But let's take out a -1 because then you also get x minus 1. Like you need the same thing twice, right? That makes sense? Okay, so long story short, this mess right here is 2x minus 1 and x minus 1. That's your moment. So hopefully you see it. There's a 2x minus 1 sitting there. Twice. Do you guys see that? You have the skills. You just have to be able to use them, right? And not make mistakes, which sounds easier than it is. Okay, I'd like to, now that we've done a lot of canceling here, maybe rewrite what's left, because there's not much left anymore. There is an x minus 4 left and an x minus 1 left. However, there was a minus sign. There was a third term here. There was an x minus 1 here and an x plus 2 here. You're in the way. Because I really haven't been writing this thing the whole way down. Does that make sense? Okay. Opportune moment. X minus 1, x minus 1. Can I cancel? Good. You can't. Because of the minus sign, these are now different terms. Okay, so how do we learn to subtract?
Oh, no.
Common denominators. Do they have common denominators? No, they don't. Do they have partially common denominators? Actually, no, they don't. So there is an x minus 1 right here that this term does not have. So I will put some brackets around all this stuff and put an x minus 1 here and an extra x minus 1 there. And this fraction in the front here has the x minus 1, but does not have the x plus 2. So I'm going to put the x plus 2 top and bottom. What am I doing? No, don't cancel. Some people actually have a great idea, and it's not wrong, but it's not useful. You can cancel this x plus 1 and this x minus 1, but doesn't that just undo what you just did?
Well, like the other one.
But if you cancel this one and that one, isn't that kind of the same thing of undoing what you just did? Totally correct, but not helpful. Does that make sense?
Yeah.
So next step, we now can make a big fraction. And on the bottom, I have an x plus 2 and an x minus 1. On the top, I need to do some foiling. So let me know if I lose you with the foiling. I'll try to color coordinate it here. So I'll do, running out of colors. I'll do black for this little bit. This bit, when you foil it, it'll give you x squared plus 2x minus 4x minus 8. What haven't I used recently? Yellow? Blue, I guess. Pardon me. Okay, and then you got to foil this mess over here, which will be x squared minus x plus 1. Everyone okay with that? In between, though, is a large negative sign. Don't screw up the double negatives everywhere, because like all of this stuff needs to subtract all of that stuff. That's why in that flowchart I had that little extra box there, just making sure don't forget to distribute that negative when you actually subtract. So let's subtract. X squared minus x squared is gone. Okay, you have 2x and you're minusing 4x, so that's negative 2x. And then you're subtracting another negative x, so that's like going back up by 1. So that's negative x. And then you're subtracting another negative x. That's 0? Or did I screw that up here? You have 2, you're minusing 4, you're minusing minus 1, and you're minusing another minus 1. So that's like adding 1, that's like adding 1. So that's 0, right? So that all of your x's are actually gone. Which is usually a good thing in real life too. There we go, someone laughed. Right?
Oh, okay.
Yeah?
I was like, what?
Someone finally got it. Okay. Okay, last step. You have a minus 8, and you're subtracting a plus 1, so you have minus 9. On the bottom, x plus 2, x minus 1. We're done. Because there's nothing else we can do. Okay, quick summary then. How do you add and subtract? You need common denominators. You're going to be using some skills of foiling. If you're subtracting, don't forget that double negative. It's kind of confusing. Heck, I even got confused there for a second, so be really careful. What could happen, though, is you might actually have a chance to refactor the top, and you might be able to cancel something. That could happen. But like I've been kind of harping over the last couple of days, when it comes to fractions, when the opportune moment comes, feel free to start canceling stuff. Because that's kind of the whole point of fractions. We're looking to try to find a way to cancel. And this example here was a great one where as you factor stuff, you're like, hey, look, it cancels. Okay, I think that was my last slide, right?
Yep.
Cool. Okay, so here is a running tally of things you can work on. Okay, going forward, I don't know how much time we have left today. Probably not lots. Tomorrow and Friday are work days. I gave you guys a new assignment to work on. I originally intended for the assignment to be due at the end of the week, but I'm not sure if that's reasonable. So can we play it by ear tomorrow, see how far you get with a full day to work on your next